Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions: the mystery of Pluto's heart, the mystery of Tombaugh Regio. Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction, not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. When the New Horizons spacecraft flew past Pluto on July 14, 2015, it returned images that astonished every planetary scientist alive. Instead of the dead, cratered rock they expected, they found a world of extraordinary complexity. Blue hazes, red plains, mountain ranges of water ice rising 300-500 meters above the surface, and most dramatically, a vast heart-shaped plain of nitrogen ice the size of Texas, smooth, bright white, and entirely free of impact craters. The heart, formerly named Tombaugh Regio after Pluto's discoverer Clyde Tombaugh, is genuinely mysterious. Its left lobe, Sputnik Planitia, is a nitrogen ice plain whose surface is divided into polygonal cells that are slowly turning over like boiling oatmeal, their edges constantly refreshed. This means Sputnik Planitia is geologically active, renewing its surface on timescales of thousands of years. How a body this small and this cold generates that activity is still being worked out. This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the expanding frontier of unexplained cosmic phenomena, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. Space exploration has produced many surprises, but perhaps none as persistent as the anomalies that professional scientists describe and then struggle to explain. These are not the claims of amateur enthusiasts or fringe theorists. They are the published findings of researchers at NASA, the European Space Agency, and major research universities, documented in peer-reviewed journals and presented at professional conferences, then quietly filed under requires further investigation while the scientific mainstream moves on to the next mission. The anomalies take different forms: unexpected geological features on planetary surfaces that do not match known formation processes, electromagnetic signals that arrive from directions where no known source exists, orbital mechanics of small bodies that deviate from T. Predictions of established gravitational models in ways that suggest an additional, undetected force. Each individual anomaly might be dismissed as an instrument artifact or a modeling error. But when anomalies accumulate across multiple missions, multiple instruments, and multiple research teams, the collective weight becomes harder to discount. Science advances precisely by taking anomalies seriously, by treating the things that do not fit the model as invitations to improve the model rather than as embarrassments to be minimized. The history of physics is largely a history of anomalies: the precession of Mercury that Newtonian gravity could not explain, the cosmic expansion that Einstein refused to accept, the dark matter that bends light with no visible source. Each one, properly investigated, expanded the boundaries of what we understand. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades, and patterns in science demand explanation. With that foundation in place, let us now turn to the specific case at hand. Now we reach the heart of the matter, the core evidence surrounding Pluto's heart. The mystery of Tombaugh Regio is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. Sputnik Planitia, the western lobe of Tombaugh Regio, is a depression approximately 1,000 by 2,000 kilometers in size, filled with nitrogen ice. Its total absence of impact craters means its surface is younger than approximately 10 million years, recent in geological terms. The smooth surface is constantly being refreshed by convective overturn of the nitrogen ice. This single data point, if taken in isolation, might be set aside. Anomalies happen, instruments malfunction, researchers make mistakes, but as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered the polygonal cells visible on Sputnik Planitia's surface are between 20 and 40 kilometers across and are separated by darker ridges. They are thought to be the surface expression of convection cells in the nitrogen ice. The ice is cold enough to flow very slowly, driven by the heat flux from Pluto's interior. Now, a skeptic might propose an alternative explanation for this, and that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine. Sputnik Planitia sits in a deep basin that may be the remnant of a giant impact. The basin is approximately 3 kilometers below Pluto's surrounding terrain. The combination of the impact basin and the nitrogen ice that has filled it creates a gravitational anomaly that has caused Pluto's rotation to reorient so that Sputnik Planitia faces Charon, a polar wander event driven by the mass concentration of the ice sheet. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation. But the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, Pluto's heart shape is the result of the combined albedo, brightness, of the nitrogen ice of Sputnik Planitia on the left and the eastern lobe of Tombaugh Regio, which is bright because it is covered with methane ice. Together they create the heart shape visible from Earth even before New Horizons. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of Pluto has an atmosphere. Despite its small size and distance from the Sun, it maintains a tenuous atmosphere of nitrogen, methane, and carbon monoxide that creates the blue haze photographed by New Horizons. The atmosphere is in equilibrium with the surface ices and varies with Pluto's seasons. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding: the mountains on Pluto, rising up to 500 meters, are made of water ice. At Pluto's temperatures, water ice is as rigid as rock and can support mountain-scale structures. These mountains cannot be made of nitrogen ice, which is too soft at Pluto's temperature. Taken together, these facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations. And in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain Pluto's heart, the mystery of Tombaugh Regio. This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that Sputnik Planitia formed as a result of a large impact that excavated a deep basin, which subsequently filled with nitrogen ice accumulated over billions of years. The active convection results from residual heat from the impact combined with tidal heating from Charon's gravitational interaction with Pluto. This is the mainstream planetary science interpretation. This interpretation has significant academic support and is backed by substantial evidence, but it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that Pluto's geologic activity reflects an ocean of liquid water beneath its surface, maintained by antifreeze dissolved in the water that provides a heat source for surface activity. The nitrogen ice convection is driven by this subsurface ocean, making Pluto a potential, if extreme, candidate for subsurface habitability. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that the specific shape, position, and dynamics of Sputnik Planitia reflect a combination of impact history, tidal locking, and atmospheric cycling that has created a unique and stable configuration that would persist as long as Pluto retains its current orbital relationship with Charon. What is striking about this debate is not merely that experts disagree. That is normal and healthy in science. What is striking is the quality of the disagreement. Serious researchers working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding Pluto's heart, the mystery of Tombaugh Regio, does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes the complete absence of impact craters on Sputnik Planitia, confirmed in New Horizons imagery, is direct evidence of surface renewal on timescales shorter than a proxy, mainly 10 million years. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented the polygonal convection cells visible in New Horizons images are consistent with numerical models of nitrogen ice convection driven by internal heat flux, confirming that the convective process is physically plausible. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed the gravitational orientation of Pluto so that Sputnik Planitia faces Charon is direct physical evidence that the region has an unusually high mass concentration, consistent with a thick ice sheet in a deep impact basin. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding Pluto's heart, the mystery of Tombaugh Regio. Now we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. Pluto, officially reclassified as a dwarf planet in 2006, the year New Horizons launched, proved to be one of the most scientifically rewarding destinations in the outer solar system. The data returned by New Horizons continues to be analyzed, with papers on Pluto's geology, atmosphere, and surface processes appearing regularly. Proposals for a Pluto orbiter mission are under development, which would allow the long-term monitoring of Sputnik Planitia's convective activity and the search for evidence of a subsurface ocean. Pluto's heart turned out to be one of the most dynamic features in the outer solar system. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis, and the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of Pluto's heart, the mystery of Tombaugh Regio, from the historical record, through the physical evidence, across the competing theories, and into the modern significance of what remains unresolved. What the story of Pluto Heart ultimately reveals is not just a historical puzzle. It is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process. And the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please subscribe to the channel. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment below telling us which case you want us to investigate next. The conversation continues. The investigation never ends.